As the name suggested, we have to integrate the rate law. Say we have R equal to minus dA over dt. And according to the rate law, this is also equal to K over multiplied by A power to nth value. Let's start from 0th order. We have 0th order. That means what we are going to have is minus dA over dt is equal to K A power to the 0th. So, minus dA is equal to K multiplied by 1, as anything being powered to 0th is 1, multiplied by dt. And here is where we integrate. Integral and integral. This is from A0 to AT, and this one is from 0 to t. Now, by doing this integration, we will get the equation as such. The integral over here is going to be minus AT minus A0, and on the other side we will have KT minus K0. Yeah. So what we have is minus AT plus A0 is equal to KT. Or we can also write this down so that we can find the formulation of AT to this formula, which is AT now is going to be equal to A0 minus KT. Don't forget the A here actually is the molarity. Yeah, so let me fix that. Molarity of A at a certain time equal to molarity of A in the beginning, or A0, minus the constant minus the time. Therefore, if we plot something out of this, if we plot the concentration of A over time against time, we will get a line that goes downward. So something like this. Here, the intersection of the y-axis, we will get the value of A0, while here, the gradient, so the m or the gradient, will be equal to minus k. So if we try to perform what we call a linear regression, we will get the r squared close to 0.99. That means we have a linear line. You can perform linear regression using calculator or Excel. And in this case, based on the table of the data, we have t and we have a. We use t as the x, and then we use the a as the y-axis. So then we have a pair of x and y value, and then we can try to perform linear regression. And if indeed the reaction is 0th order, then we will find that the r squared will be equal to almost 1. However, if the r squared is not close to 0.99, that means the reaction is not a 0th order reaction. We have to find another linear regression for other orders. Another concept that we will be studying here is what we call the half-life. Half-life is defined as the time required for a reaction to decrease the amount of a given reactant by 1/2. So on the other word, we can also say that, again, we have AT equal to A0 minus KT. At the half-life, the AT should be half of A0. So it has diminished or decreased by 1/2. So now let's try to solve this problem. If we have half A0 is equal to, the 0 should be outside. A0 minus KT. So in this case, what we will have is KT is equal to A0 over 2. So T will be A0 over 2K. And to denote that this is a half-life, we write the T as T half like this. So T half will be dependent on the initial concentration divided by 2 times the rate constant. The unit of T, of course, is a unit of time, depending also on the unit of K. They are very dependent on each other. It could be second, could be minute, or could be year for nuclear chemistry reactions.